Okay, so these laws they're really deep pillars. They're not proven, but they're not wrong. They're very unlikely to be wrong. Let's just go through these laws, okay, very quickly. There's a zeroth law. The zeroth law, every one of these laws basically defines a quantity in thermodynamics and then defines a concept. The zeroth law defines temperature. That's a fairly common sense idea, but it's important to define it. And I call that the common sense law. Okay, so this is the common sense law. The first law ends up defining energy, which we're going to call U. And the concept of energy conservation. Energy can't be lost or gained. And I'm going to call this the you can break even law. You can break even. You don't lose energy. You can't gain energy. You break even. The second law is going to define entropy. And it's going to tell us about the direction of time, something that conceptually we clearly understand, but it's going to put a mathematical foundation on which way does time go. Clearly, if I take a chalk like this one here and I throw it on the ground and it breaks in little pieces, if I run the movie backwards, that doesn't make sense, right? We have a concept of time going forward in a particular way. How does entropy play into that concept of time? Okay. And I'm going to call this the you can break even at 0 degrees Kelvin law. Okay? You can only do it at 0 degrees Kelvin. The third law is going to give a numerical value to the entropy. And the third law is going to be the depressing one, and it's going to say you can't get to 0 degrees. Okay, these laws are universally valid. They cannot be circumvented. Thermo is also a big tease, as you can see from my descriptions of these laws here. It makes you believe initially in the feasibility of perfect efficiency. Right? The first law is very upbeat. It talks about the conservation of energy. Energy is conserved in all of its forms. You can take heat energy and convert it to work energy and vice versa. And it doesn't say anything about that you have to waste heat if you're going to transform heat into work. It just says it's energy. It's all the same thing, right? So you could break even if you were very clever about it. And that's pretty neat. So in a sense, it says, you know, if you wanted to build a boat that took energy out of the air, out of the warmth of the air, to sail around the world, you can do that. Right? And then the second law comes in and says, well, that's not quite right. The second law says, yeah, energy is pretty much the same in all its form. But if you want to convert one form of energy into another, if you want to convert work, heat into work with 100% efficiency, you've got to go down to 0 degrees Kelvin, to absolute zero if you want to do that. Otherwise, you're going to waste some of that heat somewhere along the way, some of that energy. Okay, so all right, so you can't get perfect efficiency, but at least if you were able to go to 0 degrees Kelvin, then you'd be all set, right? You just got to find a good refrigerator on your boat, and then you can still go around the world. Then the third law comes in, and that's the depressing part here. It says, well, it's true, if you could get to 0 degrees Kelvin, you'd get perfect efficiency. But you can't get to 0 degrees Kelvin. You can't. Right? Even if you have an infinite amount of resources, you can't get there.